pretty good.
Okay, and number 3, what is the value of the test statistic? Now, the test statistic is either t or z value. Those are both test statistics, right?
I don't know.
Dang it. Here, look. I have the book open real quick.
So you
Mark
gotta use
test
a chart. Which chart is it again that we need to use for the data? Do you know which one?
Okay, so you go onto it's the quantitative inference procedures Excel tab, and then it's down at the bottom. It's the paired sample t-test is the new one that was implemented today,
Oh,
or in the last lesson at least.
I don't show that one. You're saying there's a pair one for the spreadsheets?
Yeah, it's the same one that we used last week. It's just there's another tab. There's another tab on the bottom.
Oh, another tab. Another tab. I don't see another tab.
It says one sample t-test on the bottom, and it says paired sample t-test, and two sample t-tests. All right.
It's when you open it.
Oh, that would be. I thought you were talking about online. It's the same spreadsheet.
No.
Got you. Sorry.
You're fine.
No, that's not it. It's this one. Paired sample t-test. Ah. Now you have it twice. Okay.
So.
All right, I'm ready.
Okay, so on this first one, I think we just have to find the t-score, which is the t-score formula would be, it'd be sample standard deviation. I'm confused. Because I thought this way, they weren't supposed to give us the standard. It says the standard deviation isn't known, but SD stands for sample standard deviation.
Yeah. What are you confused about?
Okay, just the t score formula.
Yeah. So we don't know the actual standard deviation, but we know the standard deviation of the data that we have.
Right.
Did you get 0.407 for the t-value?
I'm having trouble with the t formula.
Well, are you using the spreadsheet?
No. I was. I'm on the spreadsheet. He's the following. Like what's the formula you're putting in?
I'm not putting in a formula. I'm just using the paired sample test thing, and then I just plugged in the data. The data from the thing. Oh, that doesn't make sense. You're right. I see the issue that you're having with this.
Yeah, it's not asking for data yet, right?
Sorry. Yeah, no, I was using the data from the first one because I thought it would.
No, you're good. I think the number 3 is just asking for the t-test from the information given.
Yeah, you're right. Okay, do you have a piece of paper?
So D is the difference. What's the value of the test statistic?
Okay.
Value of the test- Okay. There we go. So equals D with a bar over it.
Minus u to the d over s d through n. So we get
2.
3.3 divided by sample size 3. Yeah. So it's 2.
22. Hold on, I'm almost there.
What do you say?
I got it.
Divided by square root of 9. That's what I got. 2. Okay. 4. Probability of that much. Probability of this p-value. George's hypothesis. Oh, freak. Okay. Does that mean we could use that T appellate that they gave us?
What?
Does this mean we could use the T appellate, the T appellate that they gave us in the quiz at the top?
Yeah. Just plug the stuff in. You need to add the degrees of freedom and a t-score.
Well, if we have this 2, and it's, what does the question say? Less than? Greater than Jordan's test statistic. So, over here, greater than 0.0697?
Use the probability to determine the p-value for Jordan's hypothesis test, which is hypothesis test does not equal 0. 06.
I just plugged it into that little appellate that they gave me. not the P appellate, but the T appellate at the top.
Yeah, and what you get?
Yeah, 0.0697.
Okay, so did you put the degrees of freedom at 8?
Oh no. Oh,
And then,
what the?
Since it's not equal to 0, I think you need to select both of them, and then the answer is going to be 0.0805, so 0.081 maybe.
0.08. Yeah.
I have no.
Can you explain that really quick?
Which one?
Well, what you just said. Explain that again.
Well,
You said it's greater.
Well, it says the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. So we already know that. Determine Jordan's hypothesis test, and if you scroll up and look, is U of D does not equal 0. So that means it's two-tailed, which means you're going to select greater than and less than.
Okay.
So if you select both of them, it gives you double what they just gave you. So 0.081.
I would have missed that on the test. 0.0.
I honestly, I'm guessing a little bit.
Yeah, it's alright.
That's what I think. This is cool.
Alright, number. Okay, chapter 12. Pull up this data real quick.
What do you hate for using?
The degree of freedom.
So that's greater than what we just did this one.
It's not greater than. I had a lot of fun because it says test statistic greater than Jordan's test statistic is that. Right, is the probability of his hypothesis test. Using the pointer, it's not equal to 0. So not equal means it's two-tailed point. But you have the wrong ratio. That's your answer. 0.081.
Okay, you guys ready for the next one?
Yeah, you on 5?
Yeah, I'm just getting the data up really quick. A. Copy that. Move back
Oh
up.
no.
Alright. What is the test statistic?
So 0.407.
That's what I think. The p-value is 0.689.
The test statistic.
I want to watch 5-0. It's a thought. Uh-oh. That's not good. My mom said, were you under the impression that you canceled your Boston membership? You canceled and you would be charged for 6 months. It's very bad. Usually with this, Christina.
Okay,
Like,
you
give
plug.
me 2 minutes.
You guys ready?
Yep.
Okay, so the number 5, you get 0.407.
Yep.
P value is. I like when you only have to plug the things in. 0.689.
Yep.
Okay, and what is the correct decision based on the evidence? Hold on, let's go to the top real quick. It says that the p-value is greater than that. So we reject the null hypothesis.
Yep.
Suppose the alternative hypothesis is H. MD is greater than 0. What was the correct decision based on this? It's sufficient evidence that means difference equal. Hold on. I always mess up on the word problems on those quizzes. We have some insufficient Would it be the third one? Number 8?
Number 8. I got number 2.
We have insufficient evidence of the mean of the difference.
Willing to reject it, which means you have like a lack of evidence.
Oh yeah, you're right. Okay, I'm gonna pull up B real quick.
I've never seen anybody with like such conviction. I'm not judging, I promise.
Which is greater, N or DF? Let's see, N is difference. Look for the difference or the actual value?
For which one?
For number 9, use that to answer the 8 next equation for paired samples t-test. Okay, so be sure that the t-test is not. Okay, data blah 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 is not. Okay, so difference is what the. That's weird. Did you get 22 as a difference?
At 21.
21.
Yeah. And I got 22. All right. Well, where are you getting difference?
Anyways, I have the population or N as 22, and then degrees of freedom is 21.
So N is
I'm
always
saying-
going to be greater.
Yeah, I was just looking at N. I was confused because I thought they were looking for the difference between the two.
Oh, sorry. Yeah, the difference is 22. I thought you were talking about the degrees of freedom. Sorry.
No, you're good. I'm just confused. Wouldn't the difference be 0 if they're both 22? I don't know.
Here, let me check it real quick. Means right there.
I thought it was supposed to be the difference between the standard deviation or between variable 1 and variable 2. But my Excel spreadsheet is pulling up as 22. I was a little bit confused.
Yeah. I see that. I got the same thing. Kind of confused too. Oh, I get it. Because the sample size is the same for the differences. It's talking about, it's not saying that the difference between them is 22. It's not just calculating 20. It's not calculating variable 1 and 10. I think it's just taking an average of them. Or something like that. We can see what the formula is, but I'm sure that's what it is.
Yeah, but it's just the count formula.
And then it's just going to take the difference. The mean right there for the differences is just the mean of all of the column. So this is all data for the differences. The standard deviation of the differences is 15.
Ah, you know what? You're right. Okay. Understandable. All right. So number 10.001 for the p-value. What decision would you make? I would fail to reject the null hypothesis, right? I'll go to the top real quick.
Wait,
Oh,
well,
zero.
did you get that?
What?
Which one are you doing? What'd you get for 10?
0.001?
Yeah, which means you would reject it.
All right.
Fail to reject.
Failed to reject when it be higher than the p-value would be higher than the little squiggly line. What do you call that thing?
Yeah, the level of significance.
Yeah.
0.01, so this one's less, which means we're going to reject it. And then one
Can you
above
just
is where you
try
fail to
another
reject.
one?
Greater.
Time use MD is greater than 0. You keep the same level of significance. Does the value increase or decrease? Okay, I'm going to go MD is greater than p value decreased. .001. Yeah. Okay, you got a decrease for number 12?
Yeah.
What decision do you make? I still reject the null hypothesis. Based on your response to the previous question, what conclusion can you make? There's no difference between two groups. That'd be incorrect. Would it be the third one down?
For 14?
Yeah. There's sufficient evidence that there's a mean difference between two groups. Okay. 15. How many questions are here? Jeez.
19.
Oh. We have seen the p-value depend. P-value depends on hypothesis in general. Which alternative hypothesis will give you the smallest p-value? See here. Well, in this instance, it would be greater than, wouldn't it?
I don't understand why it would be in general, though, because
Yeah, I don't get that either. In general. I don't get it because the greater than, I don't know, would be less than? I don't remember reading that in the book today.
yeah, I don't know. I honestly don't know. Yeah, I don't see why it would be like different, or
I'm
why
saying the
how it would be
the
same.
greater than wouldn't be depending on like where on the
What
numbers.
what the data is.
Yeah, so I'm super confused. I'm
Yes,
gonna say
what's
depends
the
on the
third
problem.
one? I mean, we got another attempt, so it's either the third or the fourth.
Yeah. Okay. Determine 95% confidence interval for the mean. This is from last time's thing. For the mean difference between the two groups. What? Oh no, we could do this. would be this number minus this number divided by 2. Oh. Yeah, what'd you get?
What is the point estimate for the 95% confidence interval?
I think it's 6.652. So there's you have the the lower one and the high one. And to get a point estimate, you subtract them and then you divide them by 2. Or do you add them?
Is that what the point estimate is? So what did you use to get the upper and the bottom, the upper and the lower part of the interval?
So I took the higher 18.608 minus 5.303, and then I divided it by 2 to get the point estimate.
Wait, where did you get those numbers?
On the confidence interval on the same sheet, on the same Excel thing.
Oh, well, there's an issue with that though, because that's the confidence interval for maybe.
I don't know. All it says is paired sample t-test. I'm guessing it's taking both of them into account. So, or it's taking just the difference and taking that into account. That's what the it's doing. Ooh.
Yeah,
I don't know.
that sounds right. Yeah, I think you're right.
I just don't know if it's adding or subtracting. If you add them together, then divide by 2, or you subtract them.
Let me see. Point estimate for confidence interval. Yeah, I don't know what the formula is. I can't find that formula.
Okay, we can create a confidence interval for the true mean of the differences. To do this, we follow the instructions for creating confidence interval for for a one mean deviation unknown, but we use the column of differences in the data. So that didn't tell me anything. It's the same way we do it with a single, pretty much. So I'm gonna go over here. I don't know. I think it's subtracting, but I'm not. Let me pull up yesterday or last lesson's book real quick.
Well, if you added them and divided them by 2, you'd come up with the mean.
Right. So I don't know why I was remembering like she's subtracting them. I was kind of confused by myself. Let's just add them. It makes more sense in my head.
You want? Wait, you're gonna add them?
Yeah, it doesn't make sense to subtract them.
Well,
So
if you add them though, then you just get the mean.
Yeah, the mean you get the mean of the confidence intervals.
I mean, you get the straight up mean for the differences. Like add them together, and you'll get because the middle of the confidence interval.
Oh yeah.
So
what if we subtract them?
At least subtracting them gives us a different answer.
Hold on, let me look at my notes real quick. Give me a sec. Oh yeah, subtract upper bound from lower bound to find the confidence interval for the true mean.
And divide them by 2, or just subtract them.
I don't know. I didn't say subtract. I had divide by 2 in my notes, so I thought it was, but I mean maybe not.
All right, let's just subtract and see what we get.
I'll come back to it. 17 was the margin of error and 95% confidence interval.
So 13.304.
Did you calculate that already, or did you find that somewhere?
That's what I got for the point estimate. 13.304 for the point estimate.
Oh. Try it out. I don't know. You just subtract it?
Yeah.
Yeah. I see it.
Dividing it by 2 would make some sense. Dividing it by 2 gives us a margin of error. What? Right? Isn't that right?
I don't know. Let's go back to my notes real quick. Obviously, I'm off here. Hold on. So margin of error is the t-score times.
Oh. Yeah, I think that's right. That sounds right. I'm just going to go with that because I'm running out of time here. 0.652. See what that comes up with.
Did you already submit?
Yeah, just to see what the answers were. Anything right except for the point estimate.
So the margin of error was 6.652.
652. Determine the main difference between two. Point estimate. Okay. Point estimate.
Okay. Notes one more time for the point estimate.
So, oh, you may try putting in the margin of error. See if that's right.
The same number, 6.652?
I'm gonna guess that.
Hold on. I'll look at my notes real quick. What the heck? Okay, yeah. So margin of error from data set is what we got. Okay. So where the heck is the estimate?
Do you find anything on that or no?
No, no, I didn't see anything in my notes other than it says point estimate minus point margin of error.
I think the margin of error is a point estimate for the confidence interval. I think that's what we're. Dang it, it's not the right answer. I don't know. I don't.
You didn't submit that again, did you?
On 6.652 for KD.
Oh.
I'm not gonna 19 out of 20. I don't care, but
You know what, dude? I'm gonna keep looking at this, and if I figure something out, because this is gonna take me a minute, I'll let you know if you guys want to go.
okay.
Hey, send your number over that little group message thing on, would you? And I'll just text it to you.
Awesome. Thanks.
All right, man.
See ya.
Thanks, guys.